Hi guys, welcome to the new chapter of chemistry, that is chemical bonding and molecular structure. Now in this chapter we are going to discuss about these topics. And our today's topic is types of chemical bonding. But before that, I want to discuss something with you. Let's take two most common edible things in our life: salt and sugar. The formula of the common salt is NaCl and sugar is C12H22O11. Now my question is, will salt dissolve in water? Your answer is yes, of course. Will sugar dissolve in water? You will say yes, why not? Will sugar ionize in water? You will say no. Will salt ionize in water? You will say yes, because it is an ionic compound. And if it is an ionic compound, it will dissociate into ions. It will give us Na plus and Cl minus. But my dear friends, if I consider HCl, hydrochloric acid, then hydrogen is a non-metal, chlorine is a non-metal, and they will combine to form a covalent compound. But HCl completely ionize in water, and we know that HCl is very strong acid, right? Now CaCO3, calcium carbonate, it has Ca2 plus and CO32 minus. It is ionic in nature. Does it dissolve in water? Now what you will say? It dissolves very less amount in water. So what's the answer? Let's leave the solubility. Let's talk about the shape. HCl is linear. Okay, it's diatomic. If we have polyatomic molecules, then what we will do? Like AlCl3 and PCl3. AlCl3 is planar, but PCl3 is pyramidal. Now how we will come to know that which molecule will attain which type of shape? So guys, you have to study this chapter properly. Let's discuss about ionic bonding. Now, Cossel-Lewis approach to the chemical bonding. What Cossel and Lewis did in 1916, they said that the atoms combine chemically to form chemical bonds to complete their octet or to acquire the noble gas configuration. Their view was that. So that view later on became the octet rule. Right? Now, electrons in the outermost shell are represented by dots surrounding by the symbol. So what they did, they made Lewis symbols. In Lewis symbols, they took the symbol of the elements and represented the valence electrons by the dot. For example, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Lithium has one valence electron. So you can see one dot over here. Beryllium has 2, boron has 3, carbon has 4 valence electrons, nitrogen 5, oxygen 6, fluorine 7, and neon has complete octet. Right? Now, the electrons outside, which are represented by dot, are called valence electrons. Now what is the significance of these symbols? Significance of Lewis symbols is we can find the valency of a particular element. The valency, either it will be equal to the number of valence electrons or 8 minus number of valence electrons. Let's take an example. The common example is sodium. So if I write the Lewis symbol, I will write like this. So this is sodium, and you can see that there is one dot over sodium. Therefore, we know that it is, the configuration is 281. We put one dot. The valency of sodium is 1. Let's take another example. If we take chlorine, the electronic configuration is 287, and there are 7 valence electrons here like this. There are 7 valence electrons. Now in this case what we will do, we will subtract these electrons from 8. So 8 minus 7 is equal to 1. Here valency of chlorine is also 1 and valency of sodium is also 1. So that's how we can find out the valency of different elements. Now let's start with the ionic bond. How ionic bond forms, what is ionic bond, what are the energies involved in the formation of ionic bond. Now first of all, the atom which loses the electron is called metal. Everybody knows this. And the element which gains the electron to become a negatively charged ion, that is anion, that is non-metal, right? So ionic bond can also be defined as the electrostatic force between that cation and anion. Let us study the formation of sodium chloride. This is sodium having electronic configuration 281, and you can see that this one is represented by the dot. Now on reaction with the chlorine, which is having the electronic configuration 287, having 7 electron in the valence shell, sodium will lose 1 electron and chlorine will gain 1 electron, and after this reaction we will get Na plus and Cl minus, where Na plus is a cation and Cl minus is an anion, right? And the electronic configuration of Na plus will be 28, that is of neon, and chloride will be of 288, which will be of argon. So what they are doing, they are completing their octet. Okay, now, so the atom which loses the electron is electropositive atom, that is metal. Which gains the electron, it is electronegative atom, which is a non-metal. Now let's see how NaCl forms. You can see here the electronic configuration of sodium is 281. There are 3 shells. There is 1 electron in the outermost shell of the sodium, and it goes to the chlorine, and chlorine, which is having the electronic configuration 287, the electronic configuration after accepting the electron becomes 288, that is the configuration of argon, and it becomes chloride ion, that is Cl minus, and this becomes Na plus, which is having the neon configuration, right? So that's how sodium loses the electron and chlorine gains the electron, and after losing and gaining they combine to form NaCl. Now let's discuss what type of energy changes takes place in this process. Now first of all, metal loses the electron. Now this we know that ionization energy we have discussed in the previous chapter, that it is an energy which is required to convert a gaseous metal atom into metal cation. So we have to provide some energy so that metal loses the electron, right? So first this will happen, metal will lose the electron but in the gaseous state, and that energy which is required to remove the electron from its outermost shell in the gaseous state is called ionization energy, and that is plus X kilojoule per mole we are considering here. The second energy is electron gain enthalpy, that also we have discussed in the last chapter. So X gaseous plus electron will give you X minus gas. So A plus gas is cation and X minus gas is anion. But now they are in the gaseous state. What they will do? They will attract each other and they will form a solid. So you can see here they will pack with each other. A plus plus X minus, both are in the gaseous state. They will combine and they will form an ionic solid. And when they will combine and form an ionic solid, their energy of movement will decrease. They will be restricted. And where that energy will go? That energy will come out as a heat. And that energy is called lattice energy. So what is lattice enthalpy? It may be defined as the amount of energy released when 1 mole of ionic solid is formed by the close packing of gaseous ions. So gaseous ions have very high energy, they move very fast, but when they become solid, they loses the energy. And we know that energy can neither be created nor be destroyed. So where that energy will go? It comes out in the form of lattice enthalpy. And for stable bonding, there is a simple thing: the total energy released should be greater than the total energy required. Which energy is required? Ionization energy is required for metal, and the released energy is electron gain enthalpy and lattice energy. So if our system has gaseous cation and gaseous anion, when they will come close to each other, they will release the energy. More they will release the energy, lesser they will have the energy, and lesser the energy, more is the stability. It means that we have to discuss now the condition of the stable bonding. The first one is the ionization enthalpy of metal should be low. Means metal should be like sodium, potassium, calcium, magnesium. It should be very reactive, so that we should have to give the very less amount of energy to them to eject out the electron from the valence shell, right? And the non-metal should be very reactive, so that it can accept the electron very easily, like oxygen, chlorine, fluorine. Then the ionic bond will become stable, and after that the lattice enthalpy should also be very, very high. So this is the condition for stable ionic bonding. Let's discuss the properties of ionic solids. The first one, its physical state. Ionic compounds are crystalline in nature. They are solid. The second property is high melting and boiling point. This is due to high electrostatic force between cation and anion. That's why they have high melting and boiling point. Electrical conductivity definitely in solid, since no ion is moving, that's why they will not conduct any electricity. But in case of the molten and in the aqueous medium, definitely they are very, very good conductors. And at the end, the solubility, ionic compounds are very much soluble in water and other type of polar solvents, right? So this was all about ionic bonds. Let's move ahead.